All right, we have a lot to talk about, so I'm going to get started. A few of those people, the slackers, they will miss the beginning. That's okay. Because I'm just going to start with a little history. I'm going to explain why .NET 4.0 is our biggest release since 2005. We released .NET 1.0 back in 2002. That was a good release. Then we released side-by-side .NET 1.1 in 2003. Now, the thing about side-by-side releases, you can install them both on the same machine, and that's great from an application compatibility point of view, right? You've got an old 1.0 app, it can run on 1.0, a 1.1 app can run on 1.1. Did another side-by-side release 2.0 in 2005. Now, the problem with these side-by-side releases is they're great for application compatibility, but they're not as great for add-in compatibility because your host has to choose which version of the CLR to run on. And you can either use the old one and then the new stuff doesn't work, or you can use the new one and then you can have compat issues. So we did our 3.0 release using this layer cake model. It's built on top of 2.0. We didn't change any of the 2.0 stuff. And then 3.5 on top of that. Now, meanwhile, there's all sorts of stuff way down low that we've been wanting to change since 2005. And in fact, we've been working on it. We've been checking it into an alternate branch and doing that stuff. And now, finally, in our 4.0 release, we're ready to give it to you, partially because we've solved those compat issues I was talking about. So this is actually, even though you've seen things like 3.0 and 3.5 and 3.5 SP1 in that intermediate time, even though you just saw 3.5 SP1 a few months ago, and now we've got our CTP ready, there's actually a lot more stuff here than you might imagine. So I want to just give everyone a quick reminder about what is the CLR, because there's some confusion about it sometimes. We are the bottom, the basement, the foundation, the crawl space, however you want to look at it. And other people build on top of us. So WPF, they build on top of us. WinForms, the dynamic language runtime, ASP.NET, they're all built on top of us. We build things like the JIT, the just-in-time compiler, the security model, the garbage collector, profiling and debugging APIs. The main libraries that we build are just the base class libraries, the stuff everybody else builds on top of. So all that other stuff on top, that's the subject of many other talks. We've done stuff to help them. Mostly I'm not going to be talking about that today because they're covering it in their talks, them with the beautiful graphics and the whiz-bang demos. We're going to show you the guts and the core that makes all that possible. So I'm going to talk about, I'm going to put this in 3 different sections. The first section, working better together. How we work better together in all sorts of different ways. I'm going to talk about in-process side-by-side where we work better with ourselves, believe it or not. Manage native interop. I think that was someone's pet peeve. I'll talk about a bunch of stuff we're doing there. And then I'll talk about dynamic and functional languages, both how the CLR works with them and how the improvements we're making help make sure that the languages can work with each other, the dynamic languages and the static ones, etc. Next, I'll go on to talk about various speed improvements we're making. I'm going to digress. Everything I'm talking about today is new, except for I'm going to give you a quick overview of what we did in 3.5 SP1, which was primarily stuff around startup time and install time. I'll talk about some improvements we've made to threading that will help your multi-core code get faster. Then I'll talk about some garbage collection stuff we've done that's going to address some of those latency issues we were talking about before I got started. And finally, I'll talk about some profiling improvements that will help you write faster code. In the last part of the talk, I'm going to talk about how we have fewer bugs. It's not us having fewer bugs, it's how we help you write fewer bugs. So I'll talk about corrupted state exceptions. That's that little bit around exception handling that I promised that gentleman in the middle. I will talk about better debugging, particularly dump debugging, but also mixed mode debugging. And finally, the stuff that you would have seen if you'd been awake at 8:30, code contracts. I'll give you a quick overview of that stuff. It's very cool. And it will also help address the null pointer thing that someone over there was asking about. OK, so here's the first third, in-process side-by-side, how we work better with ourselves. No PIAs, how we work better with COM objects. A native wrapping tool that makes it easier to work with Windows APIs, and support for dynamic and functional languages working better with each other. So I'm going to take a step back to explain why we did this side-by-side feature in a little more detail. And it's mainly around compatibility. So I'm going to start with a very sad story about compatibility. The .NET Framework 1.1 was highly compatible with 1.0. They really were a very compatible release. But I want to show you some code. Here's some code that someone in our IT department wrote. This was an Outlook add-in, and it was one that all of our executives used. So who can see what's wrong with this code? Just shout it out. Nobody. Okay, it's subtle. It's subtle. It's actually not that subtle. It's right there. They're initializing the thread after they've started it. Okay, and it turned out that mostly works fine because it's right after, and it takes a little while for those threads to get started most of the time, or at least it did in 1.0. In 1.1, we made that faster, and since we were doing this 8 times, most of the time, one of those threads got started before it was initialized, and then 2 threads ended up working on the same data, and they corrupted each other, and the entire thing crashed. And this was an Outlook add-in, which meant that Outlook crashed and was the one being used by all of our executives, which meant that none of our executives could use their email, and work came to a grinding halt. It also meant that they yelled at us, right? And what they said was, you said .NET Framework 1.1 was a highly compatible release. I installed it on my machine, and Outlook stopped working. And we said, well, it's not our fault. It's this bug in this IT code, and the bug was there all the time. And they're like, we don't care. We don't want excuses. We just want our email to work. And that's a problem that we have. It's a problem you have. You just want the thing to work. So, oops, there we go. Okay, so side-by-side releases solve app compat issues, right? Because your applications, they can run on the right version of the runtime, right? You can have 1.0 apps running on 1.0 and 1.1 apps running on 1.1. It's your add-in model where you have this problem, right? Where those add-ins you have to choose. You could either have, say, Outlook could host the old 1.0 version, in which case no 1.1 functionality could be used, no one would use it, they would wonder why they were paying us, we'd be out of a job, we'd be very unhappy. Or Outlook could run the new 1.1 model, in which case the 1.0 stuff breaks, the executives yell at us, and we're very unhappy. You see a pattern here? So the layer cake model was our way of addressing that, right? The layer cake model, we had the 2.0 stuff, then a 3.0 add-in can use that, and it's just adding new functionality. That's still very highly compatible. But it limited what we could do. That's why we've been holding back these great features. So what in-process side-by-side does is it lets you have your cake, namely high compatibility, and eat it too, namely get these great new features, right? And the way it works is we're actually going to run both a 2.0 based and a 4.0 based CLR in the same process, right? So you'll have at the bottom some sort of host process, say Outlook. On top of that, you'll have potentially multiple versions of the CLR running, and then the right version of the add-in running against each of those. Your old component will use the old version of the CLR. Your new component will use the new version of the CLR. Now that might or might not be what you really want, right? So we're also going to give you configuration files that will let you choose which version you want your host to run, which version you want your app to run on, which version your add-in prefers, which version it can use. We're going to give you a lot of control over this. There are some hosters for whom this is not the right solution. So for instance, SQL Server, they actually like a bunch of the new hosting features that our 4.0 release gives them. And their add-ins mostly use a relatively small subset of the CLR, so they're not as worried about the app compat issue because they think that we've preserved really high compatibility on that subset. So your hosts will have access to these new APIs. They can use things like ICLR MetaHost, etc. These will have new arguments to them that will let you control which version of the runtime you use and whether or not you want this new side-by-side behavior. The old legacy hosting APIs, those are all deprecated. Please stop using them. Okay, so that's one thing we've done. We actually have the CLR working better with itself. The next thing I'm going to talk about is exposing a native app to managed. Right? So let me talk a little bit about that today. It is a fairly miserable process, potentially. Right? So it can go like this. First, you write your native app and you want to have some COM exposure to it. You're going to run TLB imp, and that's going to generate an interop assembly. Now, let's say you did something like something crazy, like you used a pointer that was really an array, right? TLB imp will generate the wrong code. So then you're going to have to run IL-DASM. You're going to have to hand modify the IL. How many of you here actually even know IL? Wow, that's actually pretty good. Okay, well, for the rest of you, this is a fairly miserable process. And I assume that even the ones of you who know IL, you probably don't really like changing it. Now, not only do you have to change it, but you're probably going to recompile this code again later. So you probably don't want to be doing that by hand. You probably actually want to automate that process. You're going to write some JScript to automate what you just did by hand. Then you're going to run ILASM to make it all back. And then you're going to have to designate some assembly as a PS. So this is actually not a particularly fun way to do things. And then it gets worse. because now you have to deploy it, right? So you have to include it with your native app. But what if you didn't prereq .NET, right? If you didn't prereq .NET, you don't have any place to put this PIA because the GAC isn't there yet, potentially, because .NET is potentially not installed yet. So what you're going to have to do is every add-in is going to have to bring a big PIA with them, right? For Office, that's like about a 5 megabyte PIA. So you might have this 100K add-in, it's got a 5 megabyte PIA. Not particularly great experience. And then, when you move to V2 of your application, you have to update your JScript, right? Because maybe things changed a little bit. And you have to make sure everyone brings the new PIA, and you have to create publisher policy. So this is all a giant pain in the neck, and I'm sorry. And we've made it somewhat better with 4.0. So unfortunately, I can't say it's pleasant, but it is easier. One thing we've done is we've made TLB-IMP shared source. So now if you have something like that pointer that's really an array, you can modify TLB-IMP yourself and have it do the correct behavior. So we think that will be much easier to generate the correct IL in the first place than to have to, yes, applause. Oh, I like applause. Good. Let's see. But now I've lost my train of thought. Okay. Oh, yeah. So you've got the shared source. I haven't gotten very much applause before. So, okay. The place where this really gets better is what we're going to do with that PIA is at compile time we're going to consume it and we're going to pull out just the parts we need and we're going to put them right into your code. So now your add-in, instead of having to pull a PIA along with it, just the parts that need will be there. It won't be huge because we're taking just what you need. You don't have to worry about all these weird deployment issues that you used to have to worry about before. So that's actually the place where I think things get the best. Then we also have this new type identity attribute with which we can maintain type equivalence in the CLR. So if we see two things with the same type identity attribute, we'll realize that, yes, these really are the same types. Excellent. Good. Now, let's see. How many of you write p-invoke wrappers to Windows? Good. Well, you don't have to anymore. Because... we have a new tool. Someone came up with this really clever idea. Most of Windows.H has these what we call SAL annotations, and they're designed for security. They say things like, oh, this int that's a buffer length matches up with this char star. And someone realized that we could look at that information that Windows already had for most of their APIs and realize, hey, it's a char star pointer and a buffer length. That's really a string, and automatically generate the correct p-invoke wrapper. So this is our signature generation tool, and I believe that'll be up on CodePlex for you. So that'll make your lives much easier. Okay. The last way I'm going to talk about working better together is .NET and managed languages. So the .NET platform has been a great platform since its inception for multiple languages. We actually had 16 different languages at launch, but only certain kinds of languages. We didn't have any dynamic languages. We didn't have any functional languages. So now, how many of you saw Jim Huguenin's talk on the DLR? Okay, good. So some of you actually have been attending talks. That's good. So you know we're releasing Iron Python, we're releasing Iron Ruby, we're also releasing this new functional language, F#. We've done a bunch of things to make sure, we've done a bunch of things in the CLR to make sure those things work really well with each other and with other languages. So what did the CLR team have to do to enable these dynamic languages? And the answer is not much. And let me tell you why that's good, right? It proves that the CLR is really a great platform for doing these languages. If we had to do very little to enable whole new language classes, right? Jim Huguenin worked super hard and built this complex stuff on top of us, but he actually only had to ask us to change this much in order to make things work. So that's fantastic. It proves this really is a platform that's useful for lots of things. I'm going to review very quickly the 3 things that we actually did do. So big integers, these are a native type in both F# and in Python. Jim Huguenin was talking about how he asked Anders, he said, hey, what's 2 billion plus 2 billion? And Anders thought about it for a minute and said, minus 2 billion. So it's not nice to steal other people's jokes, but anyway, most of them. So we're actually going to get rid of that joke, because what we're doing is we're putting big integers into the base class libraries. And what that's going to mean is that languages like C# can get them too. So this is something, it's one of these really nice instances in which when we do something to help enable one language, every language that's built on top of the framework benefits. Another reason we're doing it in the base class libraries is to make sure that libraries will interoperate, right? So if you've got, some Iron Python libraries or some F# libraries that are mathematical, and you want to, but they're using big integer, and you want to call them or get the results in your C# code, you're going to be able to do that because we put this big integer class right in the BCL. We also want to make sure we did it right. It turns out it's easy to do a slow implementation of big integer. It takes some work to do a fast one. So we worked with the Optima team, who are mathematical experts at Microsoft. They build the Microsoft Solver Foundation, and we had them help us write that code. So it's just the best of all possible worlds. You've got fast, great code, your libraries interoperate, C# gets some of the benefits that we found in some of these other dynamic languages. I want to talk about a similar feature, namely tuples. Tuples are this construct that F# and Iron Python use, or all Pythons use, rather. So this is the syntax for, oops, nope, I didn't want to advance. That's the syntax up there for, hello world, to create a new class in F# or Python. So that'll make a new class whose members are an int and a string. So we want to make sure we put this in the BCL, in the base class libraries, to allow interoperation of libraries. And this is actually a lot harder than it sounds. It wasn't hard to implement tuples, as you can imagine. The hard part was working with all the different teams, the F# team, the Iron Python team, the C# team, making sure we came up with an implementation that all of them could be happy with and all of them could use. And that was really important because it meant that that way the code could interoperate, that you could call the libraries in one language and use them in another. And it's actually surprisingly subtle. There's things like not a number is not equal to not a number, so that could mean that if a tuple has a not a number in it, it might not be equal to itself, and what behavior does Iron Python want, and what does F# want, and can we make them be overridable in the right places? And we did it. We did it. We came up with one implementation everyone's happy with. Now, an added bonus of this is that you can now use this code, these tuples, in your C# code. So I just thought I'd show you quickly what that syntax looks like. It's super easy to use. The main place you might want to use this is a function that's returning multiple values. So imagine you have something like div and remainder, which is a function that's supposed to return I divided by j and the remainder of I over j. So here's how you would declare the tuple that it would return. Very simple with generics. Again, another generic makes it very easy to do the actual return. The var type makes it very easy to, you don't actually have to say what the tuple is, and getting access to the items is very simple. So this might be something you'd want to use if you're interoperating with Iron Python and F#. It might be something you want to use if you don't like using out parameters. Either way, it's now available to you. Everybody wins. Wow, I did not realize tuples were, you guys really like tuples that much? Excellent, excellent. So the last thing I'm going to talk about, it's a subtle thing, but it's one of those nice examples of how little we had to do. It's support for something called tail recursion in F#. How many people already here know about tail recursion? Okay, about half. So the way you do things in F#, they don't like assignments. And the way they often do stuff is with recursion. So if they want to say write factorial, that's up there as the sample code for factorial. And instead of doing an assignment, they'll call themselves. Now for something like factorial, that's okay. The recursion won't go too deep. You'll be fine. But in some cases, the recursion can go extremely deep. You can get stack overflows. People get upset. So under the covers, the compilers for some languages will convert that into iterative code like this down below, like the C# code. And it turned out that in some corner cases, for 64-bit compilers, we didn't have this fully implemented. And so that was the kind of thing we had to fix. It was just an optimization to make sure that even in those extreme cases, F# code would run great. And I just love this example because it just, A, it shows how little we had to do in the CLR, and B, it's, when we do make these changes, they benefit everyone. Okay, so that is it for managed languages working with each other. What you saw, I think the tuples are a great example. I don't think that is something we would have naturally introduced into C# to tell you the truth. because we already had things like out parameters as a way of doing multiple returns. So it's a great example where, because we make improvements for other languages, those things come back and they help everyone and give you features that I don't think I realized you people would like as much. So that's it for the section on working better together. I showed you in-process side-by-side, letting the CLR work with itself. I showed you that's letting us get that high compatibility that you all want. No PIAs is going to make it easier for managed apps to call native. The native wrapping tool is going to make it easier to work with Windows. And support in the BCL for big integer and tuples is going to preserve interop across languages and give you new features that you like in C#. The next part of the talk, I'm going to talk about how we make things faster. I'm going to talk about 4 different things we've done here. 3.5 SP1 improvements, faster install and faster startup, threading improvements that are going to give you faster parallel code, garbage collection, notification, and background collection that are going to reduce latency, and finally profiling improvements that will help you write faster server code. So this is the one, you notice how the background changed. That means this is old stuff. There's 2 old slides in this talk, both of them about 3.5 SP1. So one of the speed issues people have is the install of the framework. It can take a little while. Now, there's nothing faster than having it already there. And as you know, in Vista 3.0 is already installed. And we'll be pushing 3.5 SP1 via Windows Update. So that's great. No install needed on those Vista boxes. Also, XP boxes that already have 2.0 and above, they're automatically going to get 3.5 SP1 via Windows Update. So again, for those boxes, no install experience. But what about those XP boxes without 2.0, right? You all love the managed code. You want to make sure the framework is there. We're making it easier than ever to get it installed, easier and faster. There's a 200K bootstrapper. It's a 25 megabyte download. We're not giving you the full framework. We're leaving out things like ASP.NET that you probably don't need on your client machines. The installer is great. It's customizable branded experience. We actually download, install, and engine in parallel. So we don't wait for everything to be there before we start engineering it. So the entire thing installs and engens in just a few minutes. We've also really thought about the end user experience, the speed of their experience. It's 3 clicks to install, 1 for the XE, 1 for the CERT, and 1 for the EULA. So that's making the install much faster. Another pain point, I'm surprised no one mentioned it before, is startup time. And we've done a lot to address startup time in 3.5 SP1. Some apps will see up to 40% improved startup time, which we think people will appreciate. While I'm digressing and talking about 3.5 SP1, I'm going to just talk about a few other great things it brought with it. Running from the network share with full trust. That's going to make it a lot easier to deploy your applications. Faster WPF. We didn't do this. This is stuff other teams did, but that's also going to make things faster. More WinForms controls, lots of ASP.NET improvements, Visual Studio improvements for HTML and JavaScript. So the great thing about this is there's really going to be more scenarios, particularly around those client scenarios where you can use the .NET framework. Okay. The next thing I want to talk about is improvements for parallel computing and threading. So one of the most popular talks so far, I believe, has been the task parallel libraries talks. People are really excited about this. We all know multi-core is coming, and unfortunately, my team didn't do very much. What we did do is all those cool statements like parallel.for and parallel.for each and p-link, those all come from another team built on top of us. And then after they did all that cool user-facing work, they came to us and they said, you know, your thread pool that they're building on top of isn't that great. And people are going to be doing a lot more thread management now that we're making it so easy for them. We want it better. So we worked with them to improve the thread pool. And this is great. It means, just so you all know, when you start a thread, it doesn't necessarily actually start running right away, right? We want to make sure we don't have too many threads running compared to the number of cores on your machine. So when you do a parallel.for, we try to have the right number of physical threads running. When you spawn a thread with .NET, we try to make sure the right number of physical threads are running. If those threads start blocking, we may need to spawn more. So we have some interesting algorithms for making sure that's done right. And with these new things coming from the task parallel library team, that we think that we're going to be running into those circumstances much more often. And so we've improved the underlying thread pool code working with them to come up with some great algorithms for doing that. But that also means that your code, your legacy code that was spawning threads, that's going to get better too. So it's another nice example where our partner demands are making things better for everyone, whether you use the new stuff or not. Next, I wanted to do to talk about garbage collection. Garbage collection is wonderful. It eliminates all sorts of bugs. It does occasionally lead to pauses. Now, our Generation 0 and our Generation 1 collections, those are very fast, as I think you all know. It's when the Generation 2 large object heap collection happens that things can sometimes get slow. We actually use different algorithms for server and for what we call workstation, which most people would call client. And so I'm going to talk about the things we're doing to improve both of those and to reduce the latency there. So let me start by showing you what we're doing to reduce latency on the server. Our server algorithm is a great algorithm. It maximizes overall throughput, which is what we think people want to happen on the server. But it makes a trade-off. It pauses everything while the Gen 2 collection is happening. That turns out to let you have higher throughput, but at the cost of that pause, that latency. So what we've done is in CLR version 4, we're allowing you to be notified before that Gen 2 happens. That's not going to help everyone, but it will help people who have a load balancer. So what we think those people will now be able to do is they'll be able to say, oh, a Gen 2 collection is happening. I'm going to redirect the traffic away from my web servers, from the web server that's going to get that Gen 2 collection, and direct it over to other web servers that aren't going to have a pause. And so then your users won't actually see that latency because they won't be using that server. So I'm just going to quickly walk you through what that code would look like. You're going to need to call gc.register for full GC notification. And you're going to have to find some parameters that are right for you. These give you, we don't know how long it is. We don't know in seconds how long it is till the next garbage collection. We just have some idea of how full the heap is. And you're going to have to tell us, hey, I want to be notified at this time. You're going to have to play with those numbers. Then the next thing you're going to have to do is start up a new thread that's going to wait for that notification to happen. And then after that, you're going to have to actually call this gc.wait for full GC approach. That's a blocking call. When that succeeds, you know that that Gen 2 garbage collection is almost here. At that point, what you want to do, this is where your own code comes in. You have some work to do. At that point, what you want to do is you're going to have some sort of on full GC approach notify code you would write yourself. And that code is going to have to tell your load balancer, hey, stop sending me traffic. You're going to wait for your queues to drain. And now don't forget to do this part. Then you're going to have to call the garbage collector yourself. Normally we say, no, don't call the garbage collector because you'll screw it up. But in this case, make sure you call it yourself. Because since you're not getting traffic anymore, you're not going to get that GC probably. And if you sat there waiting for it to happen, it wouldn't happen and you'd just be sitting there forever. So then once you've drained the queues and called the GC, wait for the GC to complete. And then once it's completed, call your load balancer and tell it to start sending you traffic again. So we think that for people who care about latency on their servers, this is going to really reduce the latency that they see, that end users see. Now on the client, life is much simpler. That unfortunately took some work. We think people are going to be willing to do that work. On the client, we're just going to do everything for you. So I want to explain a little bit about how our background collection, I'm sorry, how our concurrent collection. Today we have something called concurrent collection. I'm going to explain a little bit about how that works. It can do most but not all of a Gen 2 collection without pausing managed code. So it's a slightly less efficient algorithm, but it leads to far fewer pauses than what we had on the server. Now, new allocations are going to go on the ephemeral segment. The ephemeral segment is where Generation 0 and 1 and parts of Generation 2 live. They actually, we think of things being moved around from generation to generation, but they're not really physically moved mostly. They mostly just sit on a segment most of the time. The problem is when that ephemeral segment fills up, we can't, with our concurrent collection today, we can't do a Gen 0 or Gen 1. So if the ephemeral segment fills up while a Gen 2 is happening, and somebody allocates memory, which since it's managed code happens all the time, it pauses. And that's when you see that latency on the client. New in the CLR version 4, we have an algorithm called background collection. And the key thing there is that we can do these Gen 0 and Gen 1 collections even while we're doing a Gen 2 collection. So if you fill up your ephemeral segment, we'll collect it. There's a tiny pause while that Gen 0 or Gen 1 happens, and then we keep going. And you see far fewer of those long pauses. They're only going to happen in exceptional circumstances now. Here's some actual results if you don't believe me. Here up on top is the old algorithm, concurrent GC. Down below, the same workload doing the new background GC. You'll see that both of them have a long pause at the very beginning. It turns out that when applications start up, they often allocate a lot of memory, and there's not much we can do about that. But once they start running, after that first long pause, but do notice that the pause is only about half as tall. And then once they start running, you'll see there's about 5 or 6 in this long pauses in the top old version, and only 1 longer pause in the new version. And that one is about half as long. So you're going to see far fewer of these longer pauses, and they're going to be about half as long. And so that's really going to improve the experience of these client apps. Good. How many of you are client people versus server people? How many server people? Good. How many client people? About evenly split. Okay, well, we'll take sides of the room afterwards maybe. Fight it out. We have to help you both. One thing we're doing for the server guys, it turns out profiling for servers is particularly hard because you often don't see the performance problems except on your live servers running in your data center. And you probably don't want to be going in and installing Visual Studio in a situation like that. And just the very act of installing Visual Studio and rebooting the server may screw up whatever performance problem you're seeing, and it may be a while till you can repro it again, and it might happen on a different box. So new in CLR 4, we've added APIs that make it easy to attach and detach performance and memory profilers to a live running server. That's going to let you see what's actually going on. Now those are only going to use the CPU sampling algorithm. We've also added, now everything I'm talking about here is available, by the way, both as APIs that any profiler or debugger can use, but also in Visual Studio itself. With one exception, the real-time heap analysis and object reference graphs, those are things we're exposing as APIs that you won't find in the next version of Visual Studio. We hope third-party applications will choose to use those and expose that functionality to you. These tools are meant to be used in a data center. There's no impact of deployment. No need to set registry keys or leave other CRUD behind. So you can go into your data center, find out what's going on, and get out. Okay, so here's the list of things we've done to make things faster. I talked about the 3.5 SP1 improvements, where the client profile installs quickly and starts faster. I've talked about the threading improvements, where we've made it easier for you to write faster code, whether you're using the task parallel libraries or spawning your own threads. I've talked about our GC notification and background collection features that are going to give you fewer long pauses. And I just now told you about the profiling improvements, where you're going to be able to see what's going on your live running servers. The last thing I'm going to talk about is how we help you have fewer bugs. So I'm going to talk about 3 things that we're doing here. The first one are corrupting state exceptions. I'm going to show you how we make it harder to make a common mistake. The next one is support for dump debugging. We're going to show you how to use the tools you already know and love for debugging your dumps. And finally, I'll talk about that code contracts work that I've mentioned a few times now. That's really cool cutting-edge code analysis. Okay, so here's another piece of bad code. Does everyone see what's wrong with this? Yes. Yeah, good. This one is easy, right? You all know you're not supposed to do this. You're not supposed to catch exception of E. And yet you do. And we're not going to let you anymore. Not quite that bad. We're not going to let you catch the very worst ones that you really, really didn't want to catch, unless you tell us you really wanted to. So what if that exception is, for instance, an access violation exception or an illegal instruction or some other exception that indicates that your whole process state is corrupt? right? You don't want to be catching those exceptions. If you do, there's a chance you'll just make things worse. The user will keep working, they'll eventually lose all their work. Or even worse, the user will save their work and it'll overwrite some persistent data. When you have something like an access violation exception, you want to get out as fast as you can before any more damage is done, right? That kind of thing indicates that, like, some pointer started overwriting arbitrary memory and terrible things have happened, and you just want to get out of there. So new, we have this corrupted state exception concept. These cannot be caught by normal catch statements. Now, these are only for some really weird things. They're for AV exceptions, they're for invalid memory. They're not for division by zero. That can happen, doesn't indicate everything's screwed up. They're not for stack overflow. That can happen, doesn't indicate that everything is screwed up. They're just for the weirdest stuff that should really never happen. Now, that said, you might actually want to catch these. But rarely. Let me talk about the two places you might want to do this. You might want to do it in main, right? You might want, for instance, write some information to a log file that says, hey, we got an AV exception. If you thought that was caused by, say, an add-in, you might want to write out, that it was an add-in and not to start up add-ins on the next run or something. So, get out doing, but making sure you do as little damage as possible. We've also seen some really rare circumstances where it made sense to catch them right next to the place where the exception happened. So you're calling some native code that you don't have control over, and every once in a while, because it's native code, it dereferences a null pointer. And you happen to go through and you look at that code really carefully and you realize, you know what, it's not really screwing everything up. Yes, it's an AV exception, but we can ignore this particular one from this particular piece of native code. It's okay. So either right at the top, around everything, or right at the point where the exception occurred. Those are the only two places we would recommend catching these. In order to help you catch them, since we're mostly ignoring those things now, we have a new attribute, handle process corrupted state exceptions. You have to put that attribute on the function that you want to catch these exceptions. And by the way, that code can only be regular code. It can't be sandbox code. If it's sandbox code, we don't let you catch it no matter what. Now, you might actually like your old code. It might be running just fine. You may have put a bunch of these catches in various places. You may know exactly what you're doing. You don't want to deal with any of this. We also have a new process-wide compat switch, legacy corrupted state exception policy. Set it to true. Everything happens the old way. Okay, so that's going to remove one common mistake. Now what should happen when you have a corrupted state exception? What should happen next? You should get a dump. And so another thing we've been doing to make your life easier is dump debugging support via iCore debug. That's the same API that Visual Studio and most other debuggers use to do debugging. And now it can look at live code. It can also look at dumps. And that's going to mean it's very easy for these debuggers to start exposing this functionality to you. It's also going to give you support for Windows error reporting mini dumps if you want to go register to get those mini dumps and see what's happening on real end user machines and then debug them. You'll be able to do that in Visual Studio now. How many of you use Visual Studio as your primary debugger? Great. And how many of you use WinDBG as your primary? Good. So you probably really do prefer to be, because you could debug these dumps before with WinDBG. This is going to be much more pleasant for all but like 8 of you. Sorry about that. So I want to show you what this looks like. Here's an example of live debugging. This is a little sample app. It just throws an exception, brings up the debugger. Here's what it looks like. Now pay very close attention. This is what it looks like for dump debugging. You all see that? Let me show you that again. Here's live, and here's dump. The main difference, if you were paying really close attention, in the bottom right corner, you'll see that's a mixed mode stack. And that is one thing. Our dump debugging is always mixed mode. Other than that, it's pretty much the same. In case you're not sure whether it's live or a dump, the easiest thing to do is to bring up the task manager, and you'll see that this code dump.exe isn't actually running. And that's really the main way you can tell that you're debugging a dump. By the way, yeah. 64-bit mixed mode supports live and dump debugging. I think that's something a lot of people have wanted for a while. I assume you're clapping for that and not the new lock inspection APIs. But actually, probably if we'd waited, you probably would be clapping for that as well. Because with the increasing predominance of multi-core, you guys are going to have to start locking more. And really, years from now, you'd be mad. So I'm giving up an applause line now and just giving you this feature early. Wow, thank you, thank you. Okay. All right. The last thing I want to talk about is code contracts. If you had gone to an 8:30 talk from Microsoft Research, or if you had gone to the very, very back of the partner pavilion before they closed it down, where the MSR booth was, you would have seen this already, but most of you didn't. So you know a lot about your code. You know things like some argument to a method is never null. You may know some things about bad inputs. You might know that an input is always greater than or equal to 0. You might know that some array always has at least one element. And lots of stuff that you know. You don't have any way really to tell the compiler about that today, right? You can do a few things. You can do assert statements, and those will check during your debug runs whether something is wrong. But it's a really fairly weak way of telling the compiler all the stuff you know. I was really impressed walking around the partner pavilion. I found 3 different booths, and maybe I missed some, all dedicated to helping you automatically find bugs in your code. But they didn't actually give you a way to say what you knew. They just sort of made guesses. They would see, oh, 4 out of 5 times you locked this, and the 5th time you didn't, so I'm going to guess that really you always want this protected, things like that. We're going to give you a way to tell the tools what you mean. So this is cool new bleeding edge stuff from Microsoft Research. So it's the new code contracts. These are in the base class libraries. And I'm going to walk you through slowly. We have something called preconditions. These preconditions are not the exciting part. They're a lot like assert. So code contract requires total cost greater than or equal to 0. That's pretty much like an assert statement. The main difference is that we also have an offline static analysis tool from MSR that can look through and automatically find violations. So if it saw that there was some code path that sent a negative number to this example function, it would be able to flag that without you even running the code. So let me just walk through this example. Imagine you have a shopping cart for some sort of retail store application. It's going to take an array of items. It's going to take a total cost so far. We know that cost better not be less than 0 when we come in, and some new item that we want to add to the cart. So there's a lot of things we know in a situation like this example, right? We know that the total cost is greater than or equal to 0. We know that the cart's not equal to null. Now I'm going to show you where code contracts start to get a little more interesting than assert statements. We have things like this for all statement, right? So we could say, for instance, that for all items in the cart, none of them are equal to the item we're passing in. That item is not already in your shopping cart. Now you could do that kind of thing with an assert statement. You could put a for loop around an assert statement, and it would do the same kind of check. But depending on how you did that, right, well, the assert would go away in the debug in the release build, but the for loop, if the compiler could tell it had no side effects, it might go away, but if the compiler couldn't, it would stay there, so maybe you need to if-def the whole thing. You can do it, but it gets messy. This makes it much easier. And the other advantage is, again, those static analysis tools. They understand things like for all, and they can automatically look for errors like, hey, did someone think that the item should be added to the cart before you call buy more stuff? So they can try to look for things like that and actually understand statements like this and in a static way find the bugs. Where code contracts start to get really interesting is what we call post conditions, this ensures. So these are things that happen when your code is exiting. Right? So often in code, there's multiple return statements out of that code. And you could put an assert statement before every single return statement and make sure it's the same assert statements, et cetera, et cetera. But it would get kind of messy, and if you forgot one place, also whatever. So what ensures does, there's a post-processing step when you use code contracts. We actually go in with a binary rewriter and rewrite your code, and we'll put these as chore statements effectively before every single return statement, so you don't have to. We can also have things like exists, that's sort of the opposite of for all. That could go in either requires or ensures, and again, that's easier to write and can be statically analyzed. There's some other cool stuff. Old value is one of my favorite features here, right? You might want to assert that the total cost is greater than or equal to the value when the function was entered. So now you could do that with debug statements. You could have with if-defs, right? You could say, if def debug, then remember the old value and then use it later, but it would, and then assert about it later, but it would just get really ugly. This is much easier. You've got a question. Okay, good. And then the most interesting place for this is exceptions, right? It can be pretty hard to do assert statements around exceptions. Imagine you want to assert that when an exception is thrown, stuff is unchanged, right? Say, for instance, that the total cost is unchanged when an exception is thrown. That's the kind of thing that can be hard with assert statements. Code contracts makes that very easy to do. So that is pretty much it. I'm going to summarize what I've talked about so far. At the beginning of the talk, I talked about working better together. I showed you how in-process side-by-side lets you safely use new stuff on existing machines. I showed you how better native managed interop makes it easier to use your COM objects and also easier to use Windows APIs. And I showed you how we have better support for dynamic and functional languages. I showed you how we make things faster with our 3.5 SP1 improvements. It's easier and faster to get installed, faster client startup. I showed you improvements around threading. Your threads are going to run a little bit faster now. And I showed you improvements for garbage collection, lower latency on the client, and ways to send traffic away on the server so your users don't see that latency. Finally, I showed you server-side profiling so you can actually look at what's going on in your lab. In your data center, rather. In the last part of the talk, I showed you how we help you have fewer bugs. I showed you corrupted state exceptions so that we eliminated that common mistake. I showed you dump debugging and mixed mode support for 64-bit. And I showed you the cool contract stuff from Microsoft Research. Now, if you've got questions about any of this, we'll be up here on stage. All of you are about to file out in 3 seconds. I will stay up here. I'll also invite people from my team up who are experts on these areas. In addition, look for a booth that looks kind of like this near that partner pavilion when you come in. It's right on the left. We have a table full of people who actually really want to meet you and talk to you, hear your questions, hear your ideas. We're near the end, so you have missed most of the cool stuff. A lot of the stuff I talked about, there was a more in-depth talk somewhere. There's only one talk coming up left that's really relevant. That's Jesse's talk that is on managed and native code interoperability best practices. That is coming up next, so you should go there. There was a contract checking talk that spent an entire hour on the code contracts, advances in the .NET type system about the managed native interop. And if you didn't see Scott Hanselman's talk, you should. Don't forget to fill out your eval forms. We love your feedback, and we will be staying here to answer your questions. Thank you all very much. So people from my team, come on up and help answer those questions. Oh, and don't forget when you're asking questions, if you can go to a mic, it's better. But you're far away. Go, start.
Okay, so the code contract with old values.
Yeah.
Now, I would think that you could contract an old value with a closure with a lambda because it would be a closure, but without it, I would think you'd be overriding. If you change the value, you're overriding that value on the stack function. So
yeah, we actually. So the question was, how does the old value stuff work? And the answer is, in the debug version, we're actually going to remember the old value. So we're going to make a copy of it. But then in the release version, we don't. So yeah, it's not really that hard to do, but it's just much nicer than having to do it manually. Is the code contract to be available? Melita, will code contracts be available in release builds? Are code contracts available in release builds?
If you use the right compiler flag, yes.
If you use the right
defined on a compiler flag, so they're conditionally defined.
So that's going to affect your code path.
Yes. Right, but so basically we don't enforce policy with. No, you can't.
Okay, so don't forget we need to repeat the question. Okay.
Yeah. So
Yeah, if anyone, I'm going to give priority to people using mics. Mics, line up behind the mic. Oh, look, there's one. What is your question?
Okay, my question is on the deployment, the 3.5 Service Pack 1. It's going to go out to Windows Update November, December, so I don't know. Is that a critical update or an optional update? Can we guarantee it's going to be on their machine?
No, we cannot guarantee. So on Vista, you're going to have to excuse me, I cannot remember the exact names of the different update types. But on Vista, it's going to be one of the top ones, and it's going to go to most Vista boxes. On Windows Update, it's going to, it will not go, I can't remember the rules, but it will not go to as many. And you cannot guarantee it will be on the machine. And in addition, you can't guarantee it's going to be on the machine anyway, because not everyone has 2.0 or higher.
No, I understand. I mean, we will put in the bootstrap for the new client profile one, but I'd hope that most machines would have it.
We will try to get it out there as much as we can.
Is there a metric? Do you want to hit like 80%, 75%, 50?
We're doing it. We're just sending it out there with Windows Update and getting it to as many people as will take it. That's what we're doing.
And has that date been announced yet?
No, the date's not yet announced.
Okay. And I didn't hear what she said about the code contracts. Is that available for release build, or do they go away?
Yeah, the answer for code contracts was that with the right compiler flag, it will stay in for a release build.
But normally does not.
I'm sorry, what?
But normally does not. You said with the right compiler flag, so
yeah, no, by default it'll be on debug only, but you can set compiler flags.
Thank you very much.
Garbage collector and background, the background garbage collection. We got some servers that are really latency sensitive. Would it be possible to run the background garbage collector on servers?
Would it be? Let me ask.
How would it
Mayone.
scale?
Is Mayone here? No. I do not know the answer to that question. Mayone. Oh, Mayone is here. Mayone, grab Mayone. I am talking to. I will get an answer for you in a minute. Next.
Yes, about the debugging stuff. You talked about the WinDBT and Visual Studio debugging. In WinDBT, you can use Son of Strike extensions. Are they planned to get into the Visual Studio debugger as well? For looking into the heaps and so on?
I'm sorry. Could you repeat that? I didn't hear that. Can you? I'm having a lot of trouble hearing the speakers. If you guys can either use the mics or just move away from the podium, it'll be much easier. I'm sorry. Can you repeat that, please?
Yeah, I was talking about the Son of Strike extensions that you can use in WinDBT for debugging.
Yeah.
And looking into the heaps. And I was wondering if they also come available in Visual Studio debugger.
Do you have an answer to that one?
So you can actually already use SOS in Visual Studio. You can load it in the command window and run commands there. But if you're talking about a more integrated experience with heap analysis in Visual Studio, not for 2010.
Okay, thanks.
Yeah. Mm-hmm.
There you go. Yeah, I've got a question about the tail recursion.
Yeah.
Is that going to be supported any better in C#? Is there going to be tail recursion supported in C#?
If I heard the question correctly, you're asking will the tail recursion optimization be available in C#? Right. And I'm not positive I have this right, but my understanding is that the compiler has to emit some special instructions to make the tail recursion work, and the F# compiler does, and the C# compiler right now does not, is my understanding. So, not yet.
Thank you.
Mayone? There's a question from the floor that I wanted to make sure got answered, which was, can you use the workstation, the new background garbage collection? Could you use that on a server if you wanted to?
Not right now, but we're looking at making that happen in the next release, approximately. I can't make any process right now, but that's one thing on our agenda.
Yeah, my question is there any chance that the C++ CLI will be supported in the Compact framework at any time?
Anyone know the answer to that one? We haven't heard anything about that. But I should say the compact framework team is a different team than ours. I don't know if we would here.
We can sync up offline.
Yeah, we can sync up offline and try to put you in touch with them and see if we can help get you an answer.
You mentioned that there's up to a 40% improvement in startup for 3.5 SP1.
Yeah.
Is that over 3.5, and how does that compare against 2.0?
I'll let Shrupa answer that question.
So it's on top of 2.0. It's actually on top of 3.5, the improvement, but it's specific to the application that you're running. And I think the applications that see the most benefit are the ones that use a lot of code from the .NET framework. The improvements were mostly around better layout of native images for the .NET framework.
Is there a slowdown between 2.0 and 3.5?
No, there is no slowdown. These were improvements in startup time. There were some improvements in code quality as well. You should not see a slowdown.
Okay, so between 2.0 and 3.5 SP1, we'll see an improvement in startup.
Absolutely, yes.
Okay,
that's right.
In 4.0, are there going to be any changes in the JIT for method inlining and for the handling of value types?
Yeah. There's significant improvements to the inliner in 3.5 SP1, but it's only for the 32-bit JIT.
Right. Is that being moved to the 64-bit for 4.0?
That is the plan. I can't make any commitments, but yes, that is definitely on the plan for 4.0.
Okay. And the same for value types?
Correct. For value types in particular, yes.
Okay. Thank you.
In our WPF and WinForm apps, we have to push all of our updates to the UI thread so that it can be handled, right? You can't, update the UI on any thread. You have to push to the UI thread. Whenever we do that, our exceptions, we get an exception. You get no stack trace. You get absolutely nothing. It just tells you an error occurred during an invoke. And we're kind of left up to having good logging to try and figure out what method in our UI is crapping out on us. Are you familiar with that at all?
We'll take that one offline. Rick will follow up with you.
The code contract, will there be any use for the compiler to remove bounds checking and stuff, or can it do something smarter?
No, it's not going to be used by the compiler. It's definitely put in the base class libraries as separate tools, but the compiler is not currently using it.
Okay. And secondly, JIT versus JIT for 64-bit. Is there any more alignment coming there because they are not on pair?
The 64-bit and 32-bit JIT?
Yeah.
Sure. Just in general, will there be more alignment?
Yeah, more features in 64-bit because it
generates.
Yeah,
there are. Shrupa, do you want to address that?
So sorry, was the question around better alignment between 32 and 64-bit JIT in terms of optimizations?
Yeah.
Yeah, so I think, so historically, the 32-bit JIT and the 64-bit JIT were built from completely different code bases. And the optimizations are different, but we did a bunch of work to, for instance, support better inlining in the 32-bit JIT. And most of that work will be done for the 64-bit JIT if everything goes according to plan in 4.0.
And are there many of these features in the 4.0 with the compiler and JIT improvements?
So in terms of features, the one thing Joshua talked about was better support for tail calls in the 64-bit JIT. And then the other improvements are mostly around using profile information to figure out how to do better inlining. A bunch of other improvements to our inliner heuristic, both on 32-bit and 64-bit.
In the JIT, are there any plans to intrinsically support vectors with SIMD instructions?
Not yet, not right now.
Long term?
But we did hear the mono talk yesterday.
Yeah,
so.
Me too.
You mentioned that the TLB importer was going to be open source, or at least on Codeplex. What about the TLB exporter?
Jesse, come on up and answer that question.
Sorry, what was the question?
You mentioned that it was mentioned that the TLB importer was going to be on Codeplex. What about the TLB exporter?
Yeah, for now we've been focusing on TLB import because that's where the vast majority of the cases where people start hand editing these things are. If you could come talk to me, I'd be curious to see what you're looking for TLB export, what changes you'd like. It'd be easier one-on-one to handle that.
You mentioned that you use layout optimizations to improve cold startup in the engine image. Are we going to be able to do the same thing for our managed assemblies? Because right now the engine just goes and puts code all over the place, and there's no way to profile guide that code generation or layout generation.
And the answer, the answer is no, right?
Yes, but there is something we're thinking. So it is true that the layout optimizations can't be done with client, like with native images, which aren't the .NET Framework's native image. But we do have a tool that we use internally to do this layout optimization. And it's in our plans to try and figure out how to make that tool available externally. I don't know at this point in time whether that's going to be doable in the 4.0 timeframe, but it's certainly in our plan to make that tool available.
All right. Well, thank you all very much. Do come either up here and chat with us. A large portion of my team is here, or come see us in the lounge. We would love to chat with all of you.